Hey, what's up, everybody, and welcome back to the Sanctuary. I'm your host, Professor C, and we're going to be continuing our A&P lecture series here today. Our very last part of the bones introduction. In fact, it's going to be another test yourself, the sixth one, where we'll take all the stuff we've learned about the skeleton thus far and quiz ourselves before we move on to the bigger section of bones where we name all the parts. So let's do a test yourself. Ready? Let's go. Sometimes the epiphyseal plate closes too early. Which of the following might be the cause? Well, it's usually caused by too much sex hormone, so let's check it out. Too much osteoblast? No. Too much thyroid hormone? No. Too much vitamin D? No. Too much sex hormone? Yes, that's it. Too much testosterone, too much estrogen can cause the plate to seal early and make you shorter, believe it or not. Spongy bone is made up of a network of blank to give it weight-bearing properties. It's got these little beams, right? These little honeycomb of beams that are called trabeculae. All right, let's find trabeculae. Lamellae, no, that's in compact bone. Trabeculae, there it is. That should be the answer. Osteons, no. And erector muscles, no, no, no. So B is correct. Moving on. Which hormone is most important for bone growth during early childhood? Well, it can't be any of the sex hormones since it's during early childhood. And I think the answer is given away in the question, growth hormone. So let's find it. Oxytocin is no. Growth hormone, there it is. I think that's going to be our winner. Testosterone, nope. Calcitonin, no. So B, yes, we got it. In the epiphyseal plate, cartilage grows. That's a little tricky one. Let's see here. Epiphyseal plate, that's the structure that allows the bone to get longer. So let's see if that helps us. It grows by pushing the epiphysis away from the diaphysis. True, it does do that because the bone is getting longer. Is that our answer already? By pulling the epiphysis toward the diaphysis. No, that would not be correct. That would make the bone shorter. In a circular pattern, no, that's not true. And under the periosteum is not applicable here either. So A was the best choice, and it wins. Which of the following glands produces a hormone that lowers blood calcium? Okay, so lowers blood calcium means we're taking calcium from the blood and putting it into the bone. So that is stimulating osteoblast activity, and a hormone that does that's called calcitonin. But they're not asking us the hormone, they're asking us the gland that makes calcitonin, which is the thyroid gland. Now that was around the block twice to get to the answer, but thyroid should be it. Pituitary, nope. Nope. There's thyroid right there, wonderful. And the tricky answer, parathyroid, but C should be correct. And it is. Which of the following hormones, so not gland this time, increase osteoclast activity to raise blood calcium levels? All right, so this is the opposite. If we're going to raise blood calcium, we need to steal material from the bones. We need to use osteoclasts to break down the bone or chew it up. And we know the hormone that stimulates that is PTH, made by the parathyroid gland. So let's look for parathyroid hormone, or PTH. No. No. Nope. There it is, parathyroid hormone. And we got it. Process whereby long bones increase their width. Okay. Well, if you get wider, it's called appositional growth. Let's see if we can find that. Oh, that was easy. We found him already. Waldo wasn't hiding very hard. There he is right there. What else do we have just in case? No. Amalgamative growth? No. Nope, none of those fit. So A, appositional growth, is whereby bones get longer. No, sorry, wider, right? They get wider. Yellow marrow, remember, is the fatty marrow made out of triglycerides. Is made up of a large percentage of, well, triglycerides or fat. Remember, butter's yellow, so yellow marrow is fatty. Hematopoietic cells, no, that's red marrow. Sharpie's fibers have something to do with the periosteum, not the marrow. Fat is definitely a great answer, even though it's real simple. That's perfectly fits that blank. And collagen does not, so fat is correct. Cells responsible for secreting osteoid are the osteoblasts, right? The blasts lay down the matrix. So I'm looking for osteo, not chondro. Osteoblast, there you are. B works. Well, yeah, not chondro, so B is the answer. Gotcha. The cell most responsible for bone resorption is again, resorption means break down and pull the material from the bone back into the blood. So if I'm going to be chewing apart bone, resorbing it, then that's the clast that does that. Not a chondroclast, but an osteoclast. So let's find osteoclast. No? No? Yes, sir, there it is. So I'm going to go with osteoclast. C. Got it. Cranial bones develop via blank ossification. Well, those are flat bones that are in the skull. So flat bones develop dermally or through intramembranous ossification. So we're looking for dermal or intramembranous ossification. Endochondral, no. That forms most of the bones, but not the flat bones. Pseudocranial, no. Intramembranous, that's the good one. We should pick it. And definitely now we should pick it because it's not ectodermal. Got it. Diplo refers to, well, diplo by definition is the spongy bone found in flat bones. So let's look for that. Serous layer, no. Spongy bone that surrounds the marrow cavity. No, that's just called spongy bone as far as I know. Articular cartilage, no, no, no. And spongy bone found in flat bones. That's perfect definition for diplo bone. A fracture in the shaft of a bone would be a break in the... I guess we're looking for just the word diaphysis here. No, not epiphysis, not metaphysis. There it is, diaphysis, perfect. And articular cartilage, no, so I'm guessing C. Winner, winner, chicken dinner. Which of the following is not a function of the skeletal system? Well, let's find the one that's not. Mineral storage is a function. Support is a function. Protection is a function. I hope this next one is not. Communication, no, heck no. The skeletal system is not about communicating, so that is our not answer. Which of the following represents the structural unit of compact bone? Well, compact bone is also known as eversion bone. And eversion bone uses those round tree ring looking things called osteons. So we're looking for osteons. Lamella, no. Lacuna, no. Osteon, there we go. And the matrix is too goofy of an answer. So osteon is the winner. Which of the following is the term for the small depressions in bone matrix where osteocytes are found? Okay, remember, you can go as far back as the tissue chapter for this one. Osteocytes are swimming around their little swimming pools called lacunae. Not lamellae. Lacunae. There we are. B is our choice. I hope, but that and that are not correct, so lacunae is our winner. Yes. The central canal houses, meaning what's inside of it? Well, blood vessels and nerves, to be specific. Arteries, veins, and nerves. Let's see what we got here. Blood vessels and nerves. That's got to be the choice already, isn't it? What else could it be? No, not matrix, not marrow for sure, not osteoblast. So A is correct. Central canals are connected to each other. Via, well, it's either the old school Volkmann's canals or More modernly, they're called perforating canals. So let's find one of those two. Canaliculi, no, they connect osteocytes to each other. Perforating canal, that's it. That's the modern term for a Volkmann's canal. That should be the answer. Marrow cavities, no. And spicules, no. So there's our answer. Perforating or Volkmann's canals. The periosteum, again meaning literally around bone, is secured to the underlying bone tissue via, well, what holds the periosteum on? Those little fibers called Sharpie's fibers, old school style. More modernly, they're called perforating fibers. Let's find Sharpie's or perforating fibers. Canaliculi, no. Volkmann's canals, no. There they are, Sharpie's fibers. That's our answer. And Bowman's threads, no, not even. So we got that one too. Awesome. Hey, perfect timing. That's the end of that one. How'd you do? If you didn't do so hot, try it again until you get them all right. All right. Thanks for watching that one. If you want, check out the other ones and the many more to come in the future. I'll see you around the block. Bye-bye.